Good morning, my name is Muhammad Faris bin Muhammad Jafar. My matric number is S47276. My supervisor is Dr. Auni Asnaf bin Madad. My project thesis is entitled by Mathematical Modeling and Stability Analysis of Drug Addiction. First and foremost, let us know the keywords. Mathematical modeling is the description of a system using mathematical concepts and language. And stability analysis is the analysis of how a model reacts to its change. The population dynamics is the study of how and why the population change in size and structure over the time. In Chapter 1 Introduction, the research background is the abuse of the drugs occur when the person becomes addicted to the intake of illicit drug. He used it as a form of escapism, gaining confidence as many more. The serious public health issue that in some way affects nearly every community and family. The problem statement is that the number of drug addicts from 2014 until September 2018 is 133,684. There are 75 million people have been infected with HIV and 30 million of them are died. The total economic burden is 78.5 billion US dollar. Therefore, the mathematical model and stability analysis performed may help the government to manage the spreading of drug addicts within the population. The objective in this thesis are to formulate a mathematical modeling of the drug addicts population. Second, to find the equilibrium points for the drug addicts model. And third, to evaluate the local stability analysis to understand the behaviors of the drug addicts model. Here you can see the literature review from 5 different journals, which is the year of publication from 2012 and 2018. In Chapter 3 methodology, we use using the compartmental modeling, which is the SIR model, also known as susceptible, infected, and recovered. Here you can see the flow diagram, and this is the ordinary differential equation that is formed based on the flow diagram that we shown earlier. And the steps to find the stability analysis is 7 steps, which is first, determine the equilibrium points. Second, analyze the obtained equilibrium points from the system. Third, the computation of the general Jacobian matrix. And fourth, Jacobian is determined at the point of equilibrium. And 5, the determinant J minus lambda I equal to 0 is the roots of the characteristic polynomial. 6, identify the type of local stability of equilibrium points. And lastly, repeat the steps 3 until steps 8 for all equilibrium points that we obtain. Here you can see the structure of Jacobian matrix, where the partial derivative of Fi with respect to Sj is shown as follows. Instead using the eigenvalues, we use the Rule-Hurwitz criteria because it is more easier to find using the 3x3 matrix. Here is the polynomial and the Hurwitz matrices. In Chapter 4 result and discussion, this is my flow diagram, which is UN equal to UAQ. U is the number of people who may or not become the drug user. A is the drug user without HIV, and Q drug user having HIV. And here you can see the description of state variable and the parameters of the model. In 4.2 stability analysis, there are 3 ODEs that I obtained, and there are 3 sets of equilibrium points that I obtained using the simultaneous equation. The Jacobian matrix of the model is given by as follows, and then the Jacobian matrix is evaluated at each of the set of equilibrium points. Next, we evaluate determinant J minus lambda I equal to 0, where I is the identity matrix. Then we can find the characteristic polynomial P1 lambda until P2 lambda and P3 lambda. The local stability of the equilibrium points is analyzed by using Rule-Hurwitz criteria from the computation above. All the equilibrium points are locally asymptotically stable if and only if the conditions of Rule-Hurwitz criteria are satisfied. The last but not least, the purpose of the research is to study the population dynamics of drug addicts population. The mathematical model consists of 3 state variables. There are 3 sets of equilibrium points that are locally asymptotically stable if the conditions of Rule-Hurwitz criteria are satisfied. As a conclusion, all of the objectives in this research can be achieved. In the recommendation, in future study, the global stability of each equilibrium point can be analyzed to study the dynamic behavior of the model. Furthermore, the numerical simulation can be constructed to verify and illustrate the analytical result. Besides, the sensitivity analysis can be computed to determine the dominant model parameters. Here is my reference from other journal and other websites. Thank you for listening.